Hello.
अब लाइव में एक बार देख लें सब करेक्ट है कि नहीं। हम पहले ज्वाइन हो जाए। मैं क्या शो कर रहा हूँ अभी। जो मीटिंग से कनेक्ट करना होगा ना मुझे, किसी एक को फ्री होने की जरूरत है। सर आपकी हेल्प चाहिए, ये कनेक्ट करना है मीटिंग से लैपटॉप को। Okay. So let's see how many participants we have. Okay. Okay. Ready? Ready to go? Stop. So hello everyone. How are you all? Please write it down on the comment section. If you are here, please write down hi. Hi, Shail. So right now we are going to take some deep dive into the sky, and we are going to observe many deep sky objects. But first of all, let me thank to all the people who made this thing possible. A special thanks goes to Miss Sangeeta Chakravarti, principal ma'am of the school, DPS, Sector 19, Faridabad. And right now we are all live from SOAR Observatory, that is Space Observatory and Research Center. So now, again, a special thanks to Vice Principal of this school, Mr. Sandeepan Rishi, and all the management of this school and the whole DPS society to be part of this fabulous event today. Now we will go further to our things in the sky. But first of all, let me make you go through the whole history of sky observation. For that, small, small, very minute question for you. Now, I hope you can see this screen over here. So, in these two photographs, the upper one is just to get the dramatic effect of that place, and the bottom one, that image is the image of a country, a very famous country, famous for its longest river in the world. That is Egypt. And the river right now that you are seeing is Nile. But the question is, why am I showing you this river? So that I can tell you where the whole journey of observing the sky started. Because right now we are going live and trying to get as much people as possible to get down and start to observe the night sky with the very, very sophisticated equipments at the side. As you can see, this is a large telescope that we have at my back that is right now pointing in the sky. And right now we are trying to observe a galaxy itself, a very huge galaxy. So we didn't come here directly. We had a very long journey of doing so. And this river is resonating with that story. It is the story for it's about 5,000 years ago. People living near that river, they understand that understanding the sky is very crucial for their survival, for their life cycle, because it tells them about the changing weather. And the most importantly, the flood are all worrying about. Because every year, they have to encounter with a flood, a very massive flood. And many people lose their lives. People lose their lives. People lose their food to survive. So that's why they understood that we need to understand at what time of the year these floods come. And these were cyclic. Every year these floods come, but they could not track the time. They could not track the calendar. They could not track the year, the cycle of the season. So that's when they understood. Not all the people at the same time, but some people understood. The sky has a pattern, and the pattern changes every year. And they understood that one star, particularly, the brightest star in the night sky. And who can tell me what is the name of the brightest star in the night sky? Please tell me down in the comment section. What is the name of the brightest star in the night sky? I'm waiting for 10 seconds. Yes, very good. It is serious. Someone is writing down Venus as well. Venus is, we call it the morning and evening star. It's not a star, it's a planet. So the brightest star is Sirius, actually. Very good. Are you serious? Okay, I hope I am visible. Okay, so Sirius is a star that whenever it comes in the sky after few days, when it appears in the sky, for people in Egypt, flood comes. Flood comes every year, just after few days when they could see the brightest star in the night sky. That is Sirius. So Sirius becomes a very serious problem for them. Now can you see it? So they understood that fact that the sky has a cycle, that it moves in a cycle, and every year the cycle repeats itself. And whenever that star is visible in the night sky, no, because not all the the stars can be visible at all the times. So that's why whenever that star is in the sky, the Sirius in the sky, they always just run away from the river. They just take up and accumulate all the food that they can have. They gather all their resources and they just run for their life. So that's how they got to survive by understanding the pattern in the sky. So that's how the whole journey started. So that's why it became the matter of survival itself to start to study the sky, understand the cycle of the day and night, to understand the cycle of the months, because at the completely dark phase of the moon, that is the new moon time, it's very, very tough to survive in the night time because predators are just waiting for that time and they are going to hunt for their prey. So that's why it was important for everyone who is having that tribes, who are living in the tribes and going along. If they are not predators, they become the prey. So that's how it was very, very important for them to understand the pattern in the sky. So that was the one thing. Now, goes from that part, the ancient era, to the medieval ages. People like Galileo Galilei, Isaac Newton, and then people like William Herschel, and then people like Edwin Hubble and Einstein. They all made it more significant for the people to understand it. That the world that we live in right now got shaped because of understanding the space itself. Otherwise, the technological advancements that we have, the curiosity that we have built till now, nothing would have happened if we did not have understood the sky, we did not have observed the sky. So that is the basic review of the astronomy, the long astronomy age. Right now, you see something where I'm showing you these kind of celestial bodies. Now, so these are some of the bodies. When we look into the sky, these kind of things that we can encounter. Sometimes we can see moons, not just our moon, different moons like Titan, like Ganymede. Many moons we can see in the sky. And surely we can see stars, our sun also in the daytime. Otherwise, stars in the night sky. And it's and comets and asteroids and other deep sky objects. Do you know that we have divided the sky into two parts? The normal objects that we see, we cannot say normal objects, but the solar system objects and the deep sky objects. The things that are not part of our solar system, these are the deeper part of the sky. That is very hard to be seen with the naked eyes, but sometimes it is possible to see them, sometimes it's not. So there are some categories. Some of the deep sky objects are called nebulas, some are called star clusters, some are called galaxies, some are called pulsars, some of them are called quasars, black holes, dark matter, and more. Let me tell you, there are around 50 categories of deep sky objects that we have found. Around 50 categories itself. If I have to break them into then nine categories. How many categories? Nine. 1, 2, 3, 4, 5, 6, 7, 8, 9 categories. For example, the galaxy is not just a single category. Galaxy, we have four major categories of galaxy itself. Our galaxy is a kind of galaxy. We can in the comment section which kind of galaxy we have. Which kind of galaxy? In the comment section. Yes, very good, very good. It is a spiral galaxy. Very good. It's a spiral galaxy. We have elliptical galaxy. We have different shapes of galaxies, huh? Irregular galaxies, and many more. Annotation close. Annotation. Okay, now we are ready to move forward. So let's be ready for our first time with our telescope that we will point in the sky. That is the closest large galaxy to us, the closest full-fledged galaxy, because the galaxies could be very small and could be dwarf galaxies as well. Like Canis Major dwarf galaxy, large Magellanic Cloud. These are galaxies very close to our galaxy, but we call them satellite galaxies, very small galaxies roaming around us. A full-fledged galaxy, the biggest one, the nearest one is because the nearest biggest one. The name of the galaxy is, who will tell me in the comment section? That's very good. That's Andromeda galaxy. So can you see at the back side? Our dome is moving. Please see it there. Can you see? Our dome is moving. Can you see it? We are trying to point our telescope at Andromeda galaxy. And right now, where is Andromeda galaxy? Let me show you. Let me show you where the Andromeda galaxy is. Now, let me share the screen with you. Let me share the screen and you can see it then. Now, you can see this now. This is our night sky. This is our night sky. Right now, we are at the bottom. We are at the surface. Let me make it clear for you. Now, can you see the sky? Okay. It's going on. Very good. Now, this is our southeast direction. Let's go to the north first. Let's go to the northern part. Where is our north? This is west, and this is northwest, and here is our north. And let's find out where is our Andromeda galaxy. But first, we need to find out that place. That is Andromeda constellation. So now you need to tell me, can you see written somewhere Andromeda? Let me make it easier for you. Easy, little more easier for you. So we have Ursa Minor, and just above that, so can you see something there? Little Andromeda. Let me find it for you. Let's click on the search window. And we have Andromeda galaxy. So let's click on it. Let's find where the Andromeda is. So let's find out where what is showing up in our. Okay, now. Let's find out what we have on our screen. Let's find out. We have put our telescope on Andromeda Galaxy. We have found it. Let's find out. What can we look at? Okay. We are trying to put it on Andromeda. We are still figuring it out. Let's find out if we can find Andromeda. But first of all, let me give you a tour of this observatory. Now, as you can see my screen, I guess, in my video. So, so now as you can see that this is a telescope and we have a camera at the back. The camera is now my camera is showing up. So this camera is taking up the picture of Andromeda right now. Can you see it clearly? The camera over there at the back side of my telescope. As you can see, this camera is taking up the pictures that we are clicking from this telescope. And this telescope is let me give you a comparison. Guys, how much light it can take? It can take your eyes, the amount of light it can take, no? The diameter of your eyes, that has the take up light. Very limited, that's it. Very little. That is super small. And this is 14 inches, not 14 mm. It is 14 inches. Can you see the size? It is gigantic. It can take up at least 100 times more light than your eyes can. Let me tell you one more thing. It's not 100 times. It is much more than that because area, the light that it soak up, na, it becomes astronomically huge when you increase the area. The amount of light is the light that it can capture now gets super more than the light that we have in a small area. If you increase the diameter by 2 times, it can multifolds the amount of light that it can capture. So that's why it is more than 100 times. So I'm just giving you the idea of 100 times. The actual number is much more than that. Now you can see Andromeda. Can you see a bright patch at the center? Can you all see a bright patch at the center? This light is coming from, do you know how far the light is coming from? It is coming from a distance of 2.5 million light years away. Let me repeat it again, 2.5 million light years away. That means, student, 1 light year is a distance that is almost equal to 9.5 trillion kilometers. 1 light year equal to 9.5 trillion kilometers. That is gigantic. The distance is huge. And just you have to multiply that number by 2.5 million. Just think about the distance. And right now, the image that you are looking at is not real time. Right now, we are having the whole apparatus. Right now, we are clicking the picture live. But The image that we have got, the light that we have got is old, almost 2.5 million years old. So right now you are looking at the history. It is the time where no car was there on earth. No humans were there on earth. Humans have a history of only 2 million years. Humans, Homo sapiens, have been here for only 2 million years. This light that we are receiving is coming from a distance of 2.5 million light years away. It means it is 2.5 million years old, because uh, light takes some time no, to travel. The travel it has to go through is very long, very long. 2.5 million years it traveled to reach to your eyes, to reach to our telescope. And right now we are giving you the image. Now, as you can see, I have two images. Yes, now we have two images. On the left hand side, this image is taken from Hubble Space Telescope. As you can see, it is super clear, as you can see. And the right one is taken from SOAR, Space Observatory and Research Facility that we have here in DPS Sector 19, Faridabad. So as you can see, it is still, we cannot compete with the absolutely gigantic telescope that we have in space, that is Hubble Space Telescope, but still you can actually see the whole body of Andromeda. You can see the cloud of it. You can see that it has spread over a very large area. Let me tell you, Andromeda galaxy is almost twice as big as our compared to our Milky Way galaxy. It is huge, super huge. And do you know, right now, if we are actually comparing it with Hubble, let me tell you how Hubble works. This is one of the very fascinating image from Hubble Space Telescope. And do you know who made it? NASA made it with the help of ESA, European Space Agency. Now let me zoom it for you. Can you see that this photograph, this image of Hubble's taken from Hubble Space Telescope is not a single photograph. It is stacked and joined by more than 600 photos together. As you can see here, can you see here small photographs? So Hubble took almost 600 photographs and joined them together to create this gigantic image. And do you know how clear it is? This one is just so gigantic that we cannot fathom the sheer size of it. But the next one is a small part of Andromeda galaxy. As you can see, this is a small part of Andromeda galaxy, one part of Andromeda. And this is by far the most clear, most in-depth photograph released by NASA of Hubble Space Telescope. The size of this is around 4.3 GB. The size of this single image is 4.3 GB and it contains 1.5 billion pixels. Let me give you the idea what 1.5 billion pixels means. It means you have a high definition TV. You need more than 500 TVs to display the size, the actual size of this image. So that's how big this photograph is. That's why it is super amazing. Now you can see in the total, the sheer size of it, it can display more than 300 million. I'm telling you again, 300 million stars. If we start to count the stars inside them, you can find more than 300 million stars in it. And do you know how much time we took to take this image, the giant image, the up there, when we stacked and connected these images together? We took 12 years. So 12 years of work we are looking at right now. 12 years of work of NASA and ESA, European Space Agency. They together worked so hard for 12 years to got this image for you. So that's a big thing. I feel like clapping for them. So it's a big thing. Now, as you can see, if I give you the idea, what all that hassle, what all that hard work went. So as you can see, that small part, as you can see here, the small part, this is the zoomed in version of these small spots. You can see a nebula over there, a dwarf galaxy itself, that is called, these are called the satellite galaxies of Andromeda. So this is one of the satellite galaxy, a dwarf galaxy you can look at, and you can look at different uh, cloud of stars, star clusters, you can basically say, the giant star clusters you can see inside. You can see nebulas, the star for the active nebulas over there. So now we have found the next thing. We have found something super interesting in the sky. Actually, it was our whole schedule. So the next thing we have is for you this. Can you tell me what is it? Can you write it down for me? Is it a star? It is a black hole? Is it a nebula? Is it a star cluster? What it could be? Can you guess? In the comments, okay, let me share it for you. Let me share it for you. Now, who can tell me what is this? A star, nebula, black hole, a star cluster, a galaxy? What is it? Who can tell me? Now, this one, let me find out in the comment section. What is this? It is super easy for you to tell. Super easy. Nebula, no. It was the earlier one. This one. Write it down. What is it? This one that you can see in front of you. The left one is taken from Hubble Space Telescope, and the right one has been taken from this observatory. Space Observatory. I'm waiting for you. Let's give 5 seconds. Find out. What is it? A galaxy, star cluster, or nebula? What is it? Can you guess? Okay. What is it? What is it? Star cluster. Okay, no. It is very good. Spiral galaxy. Very good. It is another spiral galaxy. A very huge, a gigantic spiral galaxy. We call it Bode's galaxy. Named after scientist, an astronomer. His name was John Albert Bode. John Albert Bode. He found two galaxies actually. The one is here and the other one, which looked like a cigar. And we found that also. But let's see right now which kind of photograph we have, which kind of image that we can get right now. Because this image and the right side we have taken yesterday. Because right now it is not possible to take these kind of in-depth photographs right now at the moment, because we need to clear it up by doing small changes. We call it processing. We call it image processing. And we have taken the help of multiple stacking softwares, and we have stacked almost 20 to 30 images with long exposures. For example, 5 to 10 seconds at least. We have taken these photographs for long exposures of 5 to 10 seconds and then stacked at least 20 images to got you this image. So right now that you are looking at, it is the best image that we can get from this observatory right now. Not right now, in the last 24 hours. But right now I'm going to show you the current image, the live image that we can see. And where is it located? It is in Ursa Major constellation. Ursa Major constellation. So Ursa Major, the super giant constellation in the sky, in the north direction. Now, can you see it? So this is the Bode's galaxy. It is one of the bright, the huge galaxy that we can see. with normal binoculars also. If we go at dark sites, we can see it. So that's how he also observed it. Do you know when he observed it? In 1774, almost 250 years ago, he observed it. So with basic telescopes, not like this. But he has one advantage. There was no light pollution. And and do you know, now we are going for his brother, his neighbor, you could say. Let me remove it. Now let's go to his brother, or you can say a friend, or you could say neighbor. That is Cigar Galaxy. Cigar is not named after a scientist, it's just named after cigar. It looks like cigar. Let me show you the image of Cigar Galaxy. This is your Cigar Galaxy. Cigar Galaxy. It looks like cigar, na? Hai na? And let me tell you one more thing. That is a critical thing to study. That with the help of these two galaxies, na, because they are very close to each other, we understood the interaction of two galaxies when they come closer. Na, what kind of gravitational interaction they have? We understood it just because of these two galaxies when they are found in space. Cigar Galaxy and Bode Galaxy. Okay, so you can tell your friends that you have seen that two galaxies together in the sky. They are very close to each other. Um, if we get enough time now, I will also show you in the map how close these two galaxies are actually. With the help of a simulator, we call it the name of the simulator is Stellarium. So now, so it looks like a cigar-shaped galaxy, and something strange is going on at the center. Can you see something like something has blasted from it? It doesn't seem like a normal galaxy, no? It's a different shaped galaxy. The shape of the galaxy is different. Something very bizarre is happening at the center. A red color, something, a nebula type shape is coming out. Why is that? Let me give you to guess. Okay, you can guess it in the comment section. I will tell you if you are correct or not, although it's a very tough question that I have asked you. So again, the left one is taken from Hubble Space Telescope, and the right one is taken from our observatory, space observatory. So as you can see, this far object, these galaxies, these dim galaxies, we can see from our observatory as well. Now let's find out something. Someone is commenting.